Up a little, down a little. Unit 2, Linear and Exponential Functions. The ready, recursive, and explicit forms of sequence. For example, a world record cheerleading pyramid formation at the state competition has 1 girl on the top row, 3 girls on the second row, 5 girls on the third row, and 7 girls on the fourth row. The formation has 10 rows. We'll write the sequence as 1, 3, 5, 7. And the pattern is adding 2 each time. The recursive formula tells you how to get from one term to the next, which would be f of n equals f of n minus 1 plus 2, where f of 1 equals 1. This plus 2 is representing how the pattern is changing, the common difference, and the 1 is the first term in the sequence. The explicit formula for this sequence is f of n equals 1 plus 2 times the quantity n minus 1, or f of n equals negative 1 plus 2n. This 1 is this first term of the sequence. The 2 is the common difference, which is the number that is repeatedly adding to get to the next term. In this other form, negative 1 is the 0 term, what you would get if you went backwards in the sequence. And this 2 is the common difference. How many cheerleaders would be in the bottom, the 10th row? There's 2 methods to do this. Method 1, extend the pattern or use the recursive formula. Here the answer we find is 19 because that's the 10th row. Method 2, we want to use the explicit formula. So we have f of n equals 1 plus 2 times the quantity n minus 1. Since we want the 10th row, we'll substitute 10 in for n, and then we simplify. If you use the other explicit formula that we had, you're still substituting in 10 and simplifying. What's the appropriate domain for this situation? Let's put the sequence into the table. And remember, what is domain? Domain is any possible x value. So for this situation, the answer would be whole numbers between 1 and 10. In the set, you're interpreting exponential functions in context. Exponential functions can be written in the form f of t equals a times 1 plus or minus r raised to the t power. A is the initial amount when t is 0. R is the percent change. T represents time. 1 plus or minus r is where you'll find the common ratio. So in this example, we're given f of t equals 20 times 1.02 to the t power. Here 20 is the initial amount. 1.02 is the common ratio. To find the percent change, we need to take a closer look at 1.02. 1 plus r equals 1.02. So r must equal 0.02. This is the percent change. It's 0.02 or 2% growth. In the Go, we're solving two-step equations with justification. So we want to use inverse operations to undo equations and solve for given variables. For example, 2x minus 6 equals negative 2. First step is to add 6 on both sides of the equation. This is the addition property of equality because you can add the same number on both sides of the equation and the equation will stay equal. That gives us 2x equals 4. Next step is to use the division property of equality to divide 2 on both sides of the equation, which gives us x equals 2.